Hello students, first of all a very happy good morning to all of you. In the last lecture we studied about the different type of the physical quantities and their explanations. Now we are going to discuss about the dimension formula of representing any physical quantities. So let's start. What is the meaning of dimensions? Dimension is defined as dimension of any physical quantity are those powers which are raised on the fundamental units to express its unit. The expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called the dimensional formula. What is the meaning of the dimension? If you have to represent any physical quantity, that means you have to raise some power on the fundamental physical quantities representation symbolic form. That numbers are said to be the dimensions, and the representation symbolic formula is known as the dimension formula. Okay, so let's discuss the dimension formula of the fundamental physical quantities and their dimensions. So let's start. Let us see. Length, length is the fundamental physical quantity which dimension formula is square bracket L, and which dimension is 1. Why it is 1? Because we can understand here the power of L is what? 1. The power of L is what? 1. That means the dimension formula of the length is 1. Similarly, for the mass is representing by the capital M, and which is equivalent to 1. Similarly, for the time, that is also 1. Electric current, here are the two representation symbolic signs. One is ampere, the unit of the electric current, and other is the symbolic sign, that is the I. We can represent the dimension formula in both way, and their dimension is also 1. Similarly, for the temperature is represented by theta, but its unit is Kelvin. That's why we can represent the dimension formula of the temperature in both way, that is theta or K, and which dimension is 1. Similarly, for the luminous intensity, everybody knows the unit of the luminous intensity is candela, that is representing like that, and their dimension is also 1. For seventh and the last physical quantity, and that is amount of substance, that is representing by mole, and its dimension is also 1. So let's discuss some dimension formula. How can we generate the dimension formula of physical quantities? So let's start. If we have to find out the dimension formula of velocity, first example, velocity. So everyone knows velocity is represented by V, and their formula is what? Boliye, displacement upon time. Everyone knows displacement is represented by S upon T. If we have to write the dimension formula of the velocity, then it is representing in the square bracket, and we have to write the dimension formula of the given fundamental physical quantities. Everybody knows velocity is the derived physical quantities, and which is expressed in the form of displacement and time, and these are the fundamental physical quantities. If we are writing the dimensions of the fundamental physical quantities and eliminate this, then we got the final dimension formula of the velocity. As we know that the displacement is just like the length, that means the dimension formula of the displacement is L, and the time is T, which is written as LT raised to minus 1. Everybody knows the dimension formula of velocity is what? LT raised to minus 1. It is also represented like M raised to 0, L, T raised to minus 1. Okay. Here their power of the mass is 0. That means there is no need to express the mass in the velocity. Hence, this is the dimension formula. This is the dimension formula. And what is the meaning of dimension? And how can you write dimension of velocity? The dimension of velocity is written like 0 in mass. Dimension of velocity is 0 in mass, 1 in length, and minus 1 in time. So this is complete explanation of the dimension of velocity. Again I am repeating, we can write dimension is displacement upon time, velocity is displacement upon time. If we are going to write the dimension formula of the velocity, and that is written as the dimension formula of the displacement to the dimension formula of the time. If we are eliminating this or solving this, then we got the dimension formula of velocity is Lt raised to minus 1, which is written as also m raised to 0 Lt raised to minus 1. This is the dimension formula. This is the dimension formula, and this is the dimensions of the velocity, as 0 is in mass and 1 is in length and minus 1 is in time. So this is the dimension formula of the velocity. If we are going to discuss some other physical quantities, like नंबर 2 जिसको हम लोग दे देते हैं, let's acceleration. So what is the meaning of the acceleration? Acceleration is defined as the rate of change of velocity. Okay, acceleration is defined as the rate of change of velocity. That means we can write delta v upon delta t, but we can also write delta v upon t. So if you are going to write the dimension of the acceleration, and that is equal to क्या हो जाएगा, dimension of velocity upon dimension of time, and which is written as, what is the dimension of velocity? Dimension of velocity is nothing but Lt raised to minus 1, and the dimension of time is again t. Now we can write the dimension of acceleration, and that is equal to कितना हो जाएगा, Lt raised to minus 1 and t raised to minus 1, and the finally dimension formula of the acceleration becomes Lt raised to minus 2. We can also represent the dimension formula again in the fundamental form, m raised to 0 Lt raised to 0. So dimensions, this is the dimension formula, and the dimension of acceleration is 0, 1 and minus 2 in different physical quantities like mass and length and time. Okay, if we are going to discuss the third one, force. What is the meaning of force? Everybody knows force is the rate of change of momentum, but we can write the formula of force F is equal to mass into acceleration. Okay, so if we have to write the dimension formula of the force, then that is equal to कितना हो जाएगा, dimension formula of the mass and dimension formula of the acceleration. So dimension formula of the force is equivalent to dimension formula of mass into dimension formula of the acceleration, but we got the acceleration's dimension formula, and that is m raised to 0 Lt raised to minus 2. So finally dimension formula of the force becomes what? Tell me. M Lt raised to minus 2. Okay, if we are going to write the dimension, this is the dimension formula. If we are going to write the dimension, just dimension of the force, and that is equal to कितना हो जाएगा, 1, 1 and minus 2. Here is the power 1, here is the power 1, and this is the minus 2. तो ये किस में हो गया, मास में, ये किस में हो गया, लेंथ में, और ये किस में हो गया, टाइम में. Okay, that's it.